Very cool. For today, our topic is also interesting. It is database, especially relational databases, especially RDS, Amazon RDS. While it's applying, let me explain a little theory about this. So probably you're aware that almost all web application, almost every system has a front end, application layer, and also some place where it stores data. And usually in, I would say, old-fashioned traditional systems, there will be a relational database. Relational database is MySQL, Postgres, SQL Server, Oracle, what else? Probably that's the biggest names. That's the biggest titles. And in this video, I will show you how to run MySQL database on Amazon RDS. So what is, does this make sense? Like everyone familiar with, or at least heard about SQL, MySQL, and so on?
Yes.
Okay, very good. So when you have to run your own SQL server, for example, on premises in the data center, you usually have to hire a separate role called database administrator, right? And this database administrator will take care about installing SQL engine, doing backups, very important, or maybe clustering it also if we want to make it high available. So this, I would say, like, cost significant in the human labor cost. So we and Amazon simplifies this by introducing a service called Amazon RDS, which stands for Relational Database Service. What it is doing, it is giving us, like it's giving us EC2 instances, but in case of RDS, there will be some, obviously EC2s, everything is running on EC2, even for Amazon itself. But for us, there will be automatically installed database engine of our choice. It will be automatically spread across multiple availability zones. And also, it will be automatically maintained, patched, backed up, so we don't need a database administrator. We just create this RDS instance, and it works. It stores our relational data, so our application can have persistent storage, can maintain throughout instance restarts, and so on. That's how it works. That's why we have this RDS. Does it make sense?
Yes.
Okay, very good. So the next, what I'll do is we will wait a couple more minutes until it's applied. I will make sure everything is still working, and yeah, we will move forward with our RDS deployment. And if in the meantime you have questions, don't hesitate, raise your hand or just jump in and ask. Or any concerns, any questions regarding previous sessions, we have a couple minutes to discuss. Yes.
So I want to ask a question about some components. So how do we know to which subnet, whether private or public, should we attach a resource? For
Which
instance,
resource?
for load balancers, it should be attached to a public one. And
yes. So load balancers, mark it as a rule. Load balancers, if it's a public load balancer, it should always go to public subnet, even though it sends traffic to private instances.
Okay, and for autoscale groups, it should be
autoscaling
private.
group, it should be private. It can be both public and private. Private will give you more advanced security because they will not have public IP address, right? But you can also run it in public if you assign a public IP address to it, because it still needs some means to download, some opportunity to download things from the internet, clone Git repository, install the software, right? So the rule is basically simple. Load balancer distributes traffic to any subnet, doesn't matter if it's public or private, but instances in the subnet should have egress route to the internet in order for it to work. But usually, yes, usually it's one of private subnets.
Okay, thank you.
Hi, Werner.
Hey,
In SSL certificate, should I pay anything to AWS?
there is a charge, I believe, but it's not it's not significant. You will definitely afford it for testing, for these exercises. It will not cost like more than you pay for instances or whatnot. It's not significant, but yes, it most likely there is a charge for that. I don't remember how exactly they charge for this, but yes, of course, everything costs money, almost everything.
Okay, thank you.
I mean, it's not like $100 to just provision SSL certificate. It will be a fraction of a couple of cents. Okay, yeah, we don't have to. Actually, it created. Very good. Let's make sure that our website is still working. Hopefully, yes. Very good. So this particular application does not require a database, but that's okay. That's fine. In the final project, we'll use the tool. We'll deploy the thing called WordPress, and WordPress is a web application that needs access to SQL database. But for now, we just test that we are able to connect from our instances. Okay. We'll create a separate module, call it RDS, and write some code. So let's start backwards. So there will be the resource called AWS database instance. It will have an identifier. Later we'll declare this variable and pass it inside our module. How many gigabytes of storage the database should have. Database type, it could be, for example, MySQL, Oracle, Postgres, and so on. Let's use MySQL. Instance class. Similar to instance type in EC2, we can have different sizes of our database instance. It will allocate different number of CPU and memory. Name. Let's say MyDB. Username equals admin. Password equals super secret password. And yes, for those who will be watching this, it will be exposed on a video to like outside world. And if we commit this to Git, it will be also exposed to full internet. Do we have any problem with that?
Yes, sure.
Yes, obviously. And yeah, for now, that's just a simple like password that I never use, obviously. But later in the class, I will demonstrate you how to effectively and securely manage credentials for anything in Terraform, for any sensitive information that you deploy through Terraform. But for now, it will be just these hard-coded values. Multi-AZ equals true stands for clustering. So we have multiple availability zones, and when multi-AZ is enabled automatically without us having to configure anything, additional replica of RDS will be deployed under the backend, and the data will be synchronously written to the same endpoint simultaneously. That's a unique feature that AWS developed specifically for RDS, and this works for any database engine. So basically, yeah. And when an availability zone goes down, we have a second or even third, and it will even automatically switch it for us. So we won't even have to do anything. There will be like couple of seconds, perhaps, interruption, but overall it will be like very seamless. Okay. We will need to create a couple of security groups for our RDS instance. We'll do this later. Also, we'll need to create a thing called DB subnet group name, and I will explain what it means. Let's have like some backups. Actually, hold on a second. Let me check in the documentation if we really need this right now, because obviously in class we don't have to care, but yeah, only for production. Backup retention period optional. Base to playback must be between 0. Default is 0. Backup window optional. Okay, yeah. Let's not have these things. Not to overload and overcomplicate. But when you run it in production, always make sure you have your backups enabled. And this option will allow to later destroy the instance. Otherwise, it will attempt to do a snapshot and leave snapshot, and we don't want snapshot of our test sample instance to hang around and to consume money, right? Okie dokie. So, any questions so far? Okay, then let's move forward. Let's continue with our security group. $1 million question. Who knows which port is used by MySQL?
3306.
Very good. If you have any questions regarding what I am typing, this should be trivial. So far, we've done security groups millions of times already. But if you have any questions or don't understand what I'm doing, please interrupt, jump in, and ask your question. Okay? Yes.
So for the protocol, when do we use TCP and when do we use UDP?
In case of security groups, we always use TCP, I believe. I don't know if they allow UDP or maybe I'm mistaken. But in general, that's all about like difference between TCP and UDP. Do you know how they different?
By the acknowledgement message.
Yes, acknowledgement message. So let me check which protocols they have. Protocol. Yeah, TCP, UDP, ICMP. Yeah, very good. So when the resource that's behind the security group needs some UDP traffic, we obviously open UDP as well. When it requires only TCP, we only open TCP. Other option is ICMP. ICMP. Do you guys know what is ICMP?
Isn't it used for ping?
Very good. Yes. And if you want, like for some debugging purposes, for example, to allow ping, you can also open ICMP. But yeah, tricky question, interview question. Okay, we've decided to open ICMP. Which port should we open for ICMP to allow ping? Anyone? Okay, silence is good. That's because there is no port in ICMP. ICMP works in a different level of OCI model that doesn't have the concept of ports. And when I was probably maybe 5 years ago applying to searching for my new job, or maybe even 7 years ago, this was a very, very popular question. And if you hear this on your job interview, keep in mind, remember, ICMP does not use ports. Okay, source security group, yeah, okay, very cool. So this one will be our EC2 instance security group. So security groups allow not only traffic through, not only allow rules through IP ranges, but also you can say that you can accept traffic from each instance that is assigned to, for example, this security group that we provide here. You might wonder why I am calling my resources at least. Do you guys have any ideas on this matter? At least any thoughts?
Well, maybe because the replica will be called that by default. Just a guess.
Yes, I would say it's kind of default name for resource. If this resource it's the only one within the scope. And scope is limited to module. And it's kind of general good practice to call resources like that. So this means like, yes, these modules create the database, and this is the database that's created by this module. And unique naming will be delivered through higher level over here on the level of the caller. Okay, and also what we'll need is the thing called resource, called AWS database, subnet, subnet group. And let's also call it this. So why it's needed, I have no idea. For some reason, Amazon, when creating RDS, architected it this way so that you can just assign the subnets to your RDS system. You need to create a resource, an abstraction called the subnet group, and only after that, when you create your DB instances, you choose this DB subnet group, and this DB subnet group in turn has references to subnet IDs. Don't remember, have no idea, honestly, why they did so, but that's how it is. Okay, and you know what? Let's also declare these variables. Our database name, our database user, r.db support. Let's see what we have. I think we're good. Okay. And what else we need to do? We need to declare it in our level 2. And there is one more parameter called source security group ID. This should be our private security group. And we need to expose it using some outputs. Hey, this module, is it clear? Any questions, any concerns or doubts? Everyone understand what happened here in this code?
It's clear for me.
Yes.
Just a question regarding the source. Can we change the root or no? The root path.
You mean like this?
Yeah, instead.
Yeah.
Without the
can
slash.
have, without the slash?
Or yeah.
Yes. Yes, it can do like this. It can do like this. It can do any path. But in our case, we need to step out and move into the modules folder. And it also can, for example, let me demonstrate to you. And we will do this in our later class. You can store your modules, for example, remotely in, let's say, console. No. You can store them directly on Terraform.io for public modules. You can store them on GitHub. You can have a separate repository with your modules, and your colleagues from separate departments can consume these modules by referencing your repository directly. Very cool feature. I always use it myself. But for now, we are maintaining local modules, and this is meant fast. Let's try that.
I think you have added to the wrong folder.
Yeah, thank you very much. Exactly the case. Come on. I messed up all my variables. It is called db password, yes. db user and db name. db password, then db user, db name. Ah, yeah, over here. I don't know, maybe sometimes I will do entire demo without a single mistake, but not today. And it will take a couple minutes, maybe like even 10 or 15 minutes to provision the RDS. In the meantime, let's do ourselves favor and declare an output e host. So we can see the URL of our database instance directly in the browser. Sorry, in the terminal. Load balancer URL, we no longer need it. Simply because we have friendly DNS name. Nothing, it's not happening. Okay, very cool. Now we just need to sit and wait until database finally becomes available. And in the meantime, I will open AWS console and and start a session on one of our instances and explain to you how we're gonna validate that our actual DB is working. We will install a package called MySQL, and it's nothing but MySQL client. And it is still creating. Let's wait. And in the meantime, You can ask a question. Yeah.
So there was a session where we talked about metadata of instances.
Yes.
The one where we added not directly the credentials in order to get the S3 buckets.
Okay.
And at that time, you didn't find the exact endpoint to contact to get the credentials. I don't know if you had time to.
Yes. Yeah, I remember that. No, I did not have time to do this.
Okay.
But you can always check. You can always do experiment and you need to be curious yourself. And you can launch an instance and investigate the endpoint and find out the answer to this question.
I tried all the endpoints after the metadata, and I didn't find anything. So that's why I asked. But yeah, I'll do further. I'll do further.
I cannot comment on that, unfortunately. I'm sorry.
No problem. Thanks, anyways. Otherwise, for user escalation, how is it done in the EC2 instances? Like, is it done automatically or?
Like sudo?
Yeah.
You automatically have. There is a record in sudoers file that allows to run sudo for the default user without any prompts, without obviously password and so on. And yeah, you can just run sudo anytime and it will work perfectly.
How can we can prevent that from the creation of EC2 instance, or?
What do you mean prevent from creation of EC2 instance? It's just
Like when
slightly different thing. Your terminal inside is just a virtual machine. It doesn't matter where it's running. And by default, it's not even connected to Amazon API. Only if you assign a role, you get an opportunity. But it does not control any creation or deletion of instances.
I mean is when we create the EC2 instance, the user we're logging in with can escalate, right?
Yes.
Can we prevent that if we don't want anyone having access to EC2 instance?
You can simply create the easiest option in this case is to simply create an instance without an SSH key. Yes, there still will be a user, but no one will be able to connect to the shell of this user because it doesn't expose any authentication mechanism.
Thank you.
You're welcome. Also, you can modify sudoers and kind of lock this user out. But that's or alternative approach is to simply use your own custom built AMI, where you modify and wipe it out. You can even delete the user and delete its shell, and it will work. And in fact, that's how I would say increased security hardened image are being done. They don't even have a shell that you can connect to. Okay, very cool. But now let's run Terraform apply once again, so it gives us the proper endpoint as an output instead of load balancer URL. And also let's fix the deprecation. Stage name is deprecated, we should use DB name instead. Currently it's a warning, but in later versions of Terraform, it might stop working. Okay, very cool. Now, what we will do is go to our terminal session, and this is how we verify that our database is working, and run our MySQL client that we previously installed. SQL -u admin. DB name is mydb at our endpoint -p to provide a password. Secret password. Interesting. Yeah. I forgot to add -h over here. Secret password. No MySQL. Okay. Maybe without this one. Very good. Now it gives us the MySQL prompt. Let's find out how to run some queries. Probably this one will work perfectly with us. Use MyDB, the database that we created. Show tables. We have no tables. Okay, but anyways, if we connect it to MySQL, if we see this MySQL prompt, this means we were able to authenticate correctly. Okie dokie. And let's commit everything. And now what we're going to do is fix the security issue that we highlighted previously. Currently, our username, password, username and DB user not that important, but password should be hidden, should not be stored in Git as a clear text. Do you have any ideas what we can do?
Can we store it in S3 bucket?
Very good. Almost correct. We can store it, but there is a separate service in AWS called Secret Manager. And it's designed exclusively to store sensitive data, to store our secrets. So we go to Secret Manager, store new secret. We need to check other type. Don't be tricked here. You don't need to choose this one. You can choose this one, other type of secrets. Password and our password. Next. Let's say RDS. Password. Next. Next. Store. Refresh. And now we have our secret. Now what we're gonna do next? We need to somehow read this external data using Terraform. And can you guess what feature of Terraform we will use to read external information that's available somewhere else?
The backend module?
No, not the backend module. Yeah,
The data module.
yes, it is called data source. Exactly. We need to create one more data source. And the data source is called AWS secret. Let me just copy paste it. AWS secrets manager. This data source, we will provide the path to our secret, which is RDS/password. And also we'll do a couple more conversions. Actually, it works very interesting way. We need to create one more data source on top of that called secrets manager secret version, because secret manager also version controls the secret and forward the ID of the secret that we obtained through this first data source. And after that, it will be, let me actually show you how it will look like. Output temp value equals data secrets manager secret version RDS password secret string. Let's run Terraform apply. And actually, it will not allow us to see any meaningful information. I completely forgot. It automatically discovers that this is sensitive, and it will not even expose it to the output. So let me immediately just reference it in a proper format, and I will show you what it is. So it will return the JSON. We will need to decode this JSON using a special function, and take the only one parameter of the secret, which is password, and it will give us this value. I will keep this data source. Let's open RDS, and instead of this hard code, we will use this like that. Let's run Terraform apply. These attributes. Yes, that's the reason why it's not doing anything right now with the actual resource. The only thing is that it now marks it as a sensitive value because it sees that it was extracted from remote state data secrets manager secret data source. It's kind of smart in that regard. But anyways, nothing has changed. We are still able to connect using data from our secret that is stored outside of our Git repository securely. And let me commit, but what I will do is I will amend the previous commit. So I don't even expose a previous version. The code with hard-coded secret to GitHub as well. Not that I care too much about the value of this password, but because just to demonstrate how we can, and just to remind you that when you commit something and push, even if you delete it or change it, it will still be available to you in previous versions. we need to now push, create a pull request, and I believe that's it for today. If you don't have any questions, thank you for your participation today. Otherwise, feel free to ask. I'll stick around for a minute or two, but for now, the session is completed for today.
Thank you.
Thank you for today.
Thank you. Bye-bye.
Thank you. Bye.